Hi students, today we are going to discuss the kinematic equations for uniformly accelerated motion. Let an object is moving with a uniformly accelerated motion along a straight line along a positive x direction, and the following relations can be derived from this movement of this object, like position, acceleration, and the final velocity of the object. See the velocity time relation. Let v1 and v2 be the initial and final velocity of a moving object with respect to the point position x0 and x1 at times t1 and t2. Then we have acceleration is equal to delta v divided by delta t, and that is equal to delta v is the change in velocity, that is v2 minus v1 divided by delta t is the change in time, that is t2 minus t1. So where we can write A is equal to, so where v2 minus v1 is the change in velocity, and the change in velocity we can write as v2 minus v1 into A into t2 minus t1. Here the v2 and v1 are the initial and final velocities, and these final and initial velocities can be written as, the initial velocity is taken as v and final velocity is taken as u. Then A into t2 minus t1 is the change in time, that is t. So if it is the final velocity, can be written as v is equal to, and u will go this side, and u plus at, and this is the first equation of motion, v is equal to u plus at. Position time relation. Let the initial position of an object be x1 and final position of the object be x2. Let the initial position of an object be x0 at time t is equal to 0, and the final position of the object be x at time t is equal to t, and the initial velocity of the object be u and the final velocity of the object be v. Then as per the position time relation, we have x minus x0 is equal to ut plus half at square. Here the x minus x0, that is the displacement of the object, and the displacement can be denoted as the letter s. Then this equation can be rewritten as s is equal to ut plus half at square. So that is the second equation of motion. And third is position velocity relation. Let an object is moving with the initial velocity u and the final velocity v, and it is moving with a uniform acceleration a. Then as per the position velocity relation. The final velocity v of the object when it has covered a displacement s is given by v square minus u square is equal to 2as. That is the third equation of motion. Now we have seen the mathematical expression of three equations of motion. And now we are going to derive the same equations of motion by graphical method. So let us have a position time graph. And this is x-axis, y-axis, or this is the time axis and this is the position axis. So we have the object is moving with a uniform velocity. So this is the velocity graph. So it is starts, the initial velocity of the object is u and the final velocity of the object. So this is the final velocity of the object v, and at a time t this is the time t, and we give this point the initial velocity at the point A is u and the final velocity at the point B, and this point is taken as C. So we have a triangle ABC here, and the slope AB and this line gives the velocity of the or acceleration of the moving object. So since this object is moving with a uniform acceleration and this is a straight line, and this straight line indicates that the object is moving with a uniform acceleration. So the initial velocity at time t0, t is equal to 0 at the point A, and the final velocity of the object at time t at the point B. The slope of this VT graph, velocity time graph, gives, what is the slope? The slope is equal to tan theta, and this is the theta angle, this is the theta angle, okay, and the slope gives tan theta, and tan theta is equal to a BC divided by AC, okay, and BC is the change in velocity and AC is the change in time. So this we can be written as AB, BC is equal to what? Change in velocity. The change in velocity can be written as final velocity minus initial velocity, and the AC is the change in time, that is t minus 0 is the change in time. That can be written as V minus U divided by t minus 0 is equal to t. So V minus U divided by t. V minus U divided by t is equal to what? That is equal to acceleration A. So that is the slope. Slope is the acceleration, right? So slope tan theta is equal to V minus U divided by t is equal to A. That is the value of acceleration. And from this equation we can write V minus U is equal to A into t, that is AT. Therefore V is equal to U plus AT. So we derive the first equation of motion from the graph, from the same graph, and we know that the area under this VT graph, this is the VT graph, the area under the VT graph gives the displacement of the magnitude of the displacement of the object. The VT graph is a straight line AB with a point A is the initial velocity at time t is equal to 0, and B is the point where final velocity V at a time t is equal to t. The displacement of the object at time t is given the area under the VT graph, that is the area of the trapezium, that is OABCD. OABCD will be the the displacement of the magnitude of the displacement of the object. Displacement is equal to area of O, A, B, C, D. The trapezium area of trapezium O, A, B, C, D. And now that is equal to O, A plus B, D divided by 2 into O, D. That is equal to OA is what? OA is equal to U, BD. BD is equal to V, T. Then we will substitute the values. OA is U plus BD is equal to V divided by 2 into T. And from the first equations of motion, we have V is equal to U plus AT. And we are going to substitute, since V is equal to U plus AT. This value we are going to substitute in this equation. That is U plus AT into divided by 2 into T. What will get? U plus 1 into U plus AT divided by 2 into T. Then that is equal to U plus U, 2U plus AT divided by 2 into T. Then 2U divided by 2, then what will be there? U plus then AT divided by 2 into T. So that is equal to U plus half AT square. The displacement S is equal to U plus half AT square. That is the second equation of motion. And third equation of motion can be derived from the same graph. And we know that the displacement, we have already learned or calculated that the area of the trapezium OABCD. So we can write S is equal to area of OABCD. So that is equal to V minus U divided by 2 into T. So from the velocity time relation, we have V is equal to U plus AT. So from this equation we can write T is equal to, what will be the value of T? And that will be V minus U divided by A. The value of this T we are going to substitute here. Then so we can get S is equal to V minus U divided by 2 into V minus U divided by A. Okay. Now what will get? V into V, V square, U into U, U square. So V square minus U square divided by 2 into A. So that is equal to V square minus U square divided by 2A. S is equal to. And then therefore we can get, now we cross multiply this one. When we cross multiply this one, what will we get? V square minus U square is equal to S into 2A. That will write 2A into S. Equation for the third equations of motion. And this we can further write. So this is where the three equations of motion, they are derived mathematically and they are derived by graphical method.